Hello, welcome to this video. Today we're going to do this problem. So, we need to show that for any sequence of n whole numbers, a1 up until an, there exist I and j such that, well, first I smaller than j, and n divides the sum ai plus 1, ai plus 1 plus ai plus 2 all the way on to aj. So basically, if you have your sequence, you can pick a starting point and an ending point such that the sum of all numbers in between is divisible by n. So let's just do a quick example. If I have 5, 3, 7, 2, and so in this case n is equal to 4, and my sequence is 3, 7, 2. Their sum is 12, which is divisible by 4. So let's show this now for any n and for any sequence of whole numbers. So what we're going to do is look at the sequence of partial sums. So we'll write sk is the sum as I goes from 1 to k of ai. So basically a1 plus a2 plus a3 all the way on to plus ak. And then what we're going to do, because we're interested in n dividing these sums, these sorts of sums, we're going to look at it mod n. So now I'm going to write rk is sk mod n. So now I'm looking at the sequence rk. Now, if for some k rk is equal to 0, we're done. Because that means n divides the sum sk, and the sum sk is just what we're looking for, where I is equal to 0 and j equals this specific k. So if this is the case, we're done. If not, we can look at all the possible congruences mod n for rk, and we know they can be all numbers between 0 and n minus 1, but if we assume none of them are 0, we actually have n minus 1 options. Rk can only be numbers from 1 up until n minus 1. So if we have n rk's, so we have r1, r2 up until rn, and we need to put each one of these, we need to sort them into one number out of n minus 1 numbers. So we have 1, 2 up until n minus 1. Well, this maybe goes to 2, this goes to n minus 1, this goes something in between, and each number here goes to a number in this sequence. But because there are more rk's, there are n of them, and only n minus 1 possible options, we know there must be two different rk's, so ri and rj, such that I give out the same output. So there have to be two I and j's, and we'll just assume I smaller than j, such that ri is equal to rj. And if this is the case, then we know what ri is. It's a1 plus a2 up until ai, just ai, mod n. And now we know this is equal to a1 plus a2 all the way on to plus aj mod n. And because I is smaller than j, we can subtract this part from this side and this side and get that this sum, ai plus 1 plus ai plus 2 all the way out plus aj mod n is 0, or in other words, n divides this sum. So either we have that I is equal to 0, and this is satisfied, and if we assume it's not, then we have a different I, which is at least 1, because I has to be an index of R. That does still satisfy this. So finally, we proved what we wanted to. We proved what we wanted to prove. And that's it. If you want more content like this, please subscribe to my channel. I'll be uploading more interesting problems and things like this in the future. And finally, that's it.